Hey everybody, welcome back to the channel. In this video, I'm going to dive deep into the solution to free response question number 5. Number 5, here we have two particles. One, particle H, we are given the position function, and particle J, we are given the velocity function. In part A, we're asked to find the velocity of particle H at time t equals 1, showing the work. So for part A, is equal to the derivative of the position function. And we would have to use the chain rule here because it's e to a function. So it's the derivative of the function, 2t minus 4, times the original. And then we're going to plug in 1. So if you plug in 1, you would have 2 minus 4, which is negative 2. E to the, if you plug in 1, you'd have 1 minus 4, negative 3. So negative 2e to the negative 3. Part B, during what open intervals of time from 0 to 5 are particles H and J moving in opposite directions? Give a reason for your answer. Now, V of t for particle H is going to equal 0 when 2t minus 4 equals 0. So that would be at t equals 2. And we can make a little sign chart here to help us out. So at t equals 2, if we do v of 1, plugging in 1, you have 2 times 1 minus 4 is going to be a negative. E to, it doesn't matter what the power is, the e is always going to be positive. So this is going to be less than 0. And then v of 3, if you plug 3 in, you would have a positive times the e, which is going to be positive. So we know that particle H is moving to the left between 0 and 2 and to the right from 2 to 5. We need to investigate particle J equals 0 at t equals negative 1, 0, and 1. But since t has to be between 0 and 5, we can eliminate negative 1 and also 0. So I'm going to do that in a different color. The critical number for particle J is at 1. So particle J at a time before 1, let's say like 1/2, is going to be less than 0. That means the object is moving to the left. And then a value greater than 1, so like let's pick 2. V of j, when you plug 2 in, you're going to get a positive value. So notice that on the interval between 1 and 2 is where the two objects are moving in opposite directions because their velocities have opposite signs there. So we would write that in a concise statement. So there we have our statement. Now back up here for part C, it can be shown that V prime j of 2 is greater than 0. Is the speed of particle j increasing, decreasing, or neither at time t equals 2? Give a reason for your answer. So Vj of 2, we're going to evaluate it at 2 times 2 times 2 squared minus 1 cubed. That's going to be positive, so we know the velocity is positive. We know V prime of 2 is also positive by what's given in the problem. V prime 2 is greater than 0. So this is also the acceleration of particle t. So since the velocity and acceleration have the same sign, the object's speed is increasing. So there you have the statement. Part D, particle j is at position 7 at time t equals 0. Find the position of the particle j at time t equals 2. Show the work. We know that xj of 2 is equal to 7 plus the integral from 0 to 2 of 2t times t squared minus 1 cubed dt. So we know the initial position is 7. That's given in the information right here. And we want to know what the position is at 2. So we take the initial position plus the change in position. So we would have to anti-differentiate this. So you would have 7 plus t squared minus 1 to the fourth times 1/4. You would have u substitution where u is t squared minus 1. The derivative is 2t dt, and that lines up perfectly, so you don't have to adjust for any constants or anything like that. Then we're going to plug in 0 and 2 and subtract. So you'd have 7 plus 1/4 times 2 squared minus 1 to the fourth minus 1/4 of 0 squared minus 1 to the fourth. So this is going to be 7 plus 1/4. 2 squared is 4 minus 1 is 3 to the fourth power is 81. Minus, here you would just have 1/4. So what you end up having is 7 plus 80/4, which is just 20, or 27. So there you have question number 5. Thanks for watching, and if you liked this video and it was helpful, give me a like and share a comment below which problem on the AP exam this year was most difficult for you. And if you're not subscribed, please do so, and you'll always stay up to date with my most recent videos.